Savanna. Grass-dominated ecosystems that contain a significant number of widely spaced trees are termed savannas. Trees may make up as little as 5% or as much as 30% of the cover of all plants in savannas. But grasses and grass, like plant, form a continuous ground cover. Sandwiches, midway between the tropical rainforests and the subtropical high-pressure belts that produce the world's great deserts, it covers approximately 11.6% of the Earth's land surface, almost half the surface of Africa, and large areas of Australia, South America, and India. The extensive savannas are primarily a result of either the climate or unique soil characteristics. Climatically derived savannas are warm all year, but have marked wet and dry winter seasons, with high evaporation rates and annual rainfall varying widely from 30 to more than 100 centimeters. These climatic savannas are always formed in regions with a tropical continental climate where high temperatures occur. What is critical about these climates is that the rainfall is concentrated in 6 or 8 months of the year, followed by a long period of drought when rainfall amounts are very low. If the rain were well distributed throughout the year, such areas would become tropical rainforests. It is during these dry periods that the grasses are dormant and the trees experience water stress. Because the fine dry fuel, dead foliage, that the grasses produce is very flammable at this time, fires started by lightning or humans start easily and spread quickly. This combination of water stress and fire keeps the tree density low and distinguishes savanna from the adjacent forests. Other savannas occur in areas with unique soil conditions. The soil of the savanna is porous, with rapid drainage of water, and has only a thin layer of humus which provides vegetation with nutrients. Although most tropical and subtropical savanna soils are poor in nutrients, some also have a hard crust or barrier at some depth in the soil. This crust separates the shallow soil layer that the grasses rely on for water and which dries during periods of low rainfall, from the deeper soil layers that may retain moisture all year. Trees in these savannas are located at cracks in the crust where the roots of trees can access this deep soil water. Savannas formed in this way are referred to as edaphic, related to the soil, savannas. Another third type of savanna, known as derived savanna, can also occur as a result of people clearing forests or the grazing of animal herds. Farmers fell a tract of forest, burned the dead trees, and plant crops in the ashes for as long as the soil remains fertile. Then the field is abandoned, and although forest trees may recolonize, grass takes over on the bare ground, becoming luxuriant enough to burn within a year or so. Besides, a high number of herbivores are bulk feeders and browsers that can cause long-term vegetation transformation or disturb vegetation cycles. In Africa, for example, a heavy concentration of elephants in protected parkland have created a savanna by eating leaves and twigs, breaking off the branches, smashing the trunks, and stripping the bark of trees. Elephants can convert dense woodland into open grassland in a short period of time. Annual fires then maintain the area as a savanna. Fire either caused deliberately by humans, such as farmers, or naturally by electrical storms in the summer, is very common in the savanna biome at various times of the year. Seasonal fires play a vital role in the savanna's biodiversity and in helping to maintain the savanna as a grass community. It kills off weeds, competitors, and diseases, and prevents trees from colonizing relatively wet areas. And in some drier areas, fire plays a part in ensuring the height of trees and shrubs is most suitable for browsing animals to locate grasses for consumption. Due to such frequent fires, the plants and animals here have evolved various adaptations to fire, including very thick barks and thick budding that can resist burning, and the bulk of the biomass that is below ground level to aid rapid regeneration after a fire. Therefore, even in areas that get severely burned, less than 10% of the plants will die from it.